Hello and welcome to our next video in this polar coordinate series. In this video, we're going to be looking at a particular family of curves in polar coordinates called Rhodonias. And they are called Rhodonias because they are a little bit flower-like in their shape. The equation of a Rhodonia is of the form r equals a sine k theta, or we could have it with a cosine, it just rotates it by 90 degrees, where k is some positive integer and a is some positive number. All A is going to do is it's going to scale the shape up to be small or big, and K is the interesting one. So throughout this video, A is pretty much ignored because it's just a scale factor. K is the interesting case that we're going to look at. So for these examples, we're going to just draw the graphs when A is 1. And the first one we're going to consider is when K is 3. Okay, so we're going to have a look at what the graph of r equals sine 3 theta is. So for Rhodonias, there will be values of theta where r is negative because it is just a direct trig function. There's no addition of a number like there is with a limosol. So what we're going to do is we're going to, first of all, before we go into a sketch, have a think about what range of values of theta this is going to be negative for. So we know that sine of theta is positive between 0 and pi. So sine of 3 theta then must be positive between 0 and pi on 3. So we know that between 0 and pi on 3, r is going to be some non-negative number, being 0 at those extremes, 0 and pi on 3. And then in the next set of numbers, between pi and 3 and 2 pi on 3, r is going to take negative values. And then it's going to just keep repeating that process. So it's going to do it twice more to get all the way around the circle. So it's going to be between 2 pi on 3 and pi. We're going to get positive again. And then between pi and 4 pi on 3, r is again going to be negative. And then similarly for the last two sections, we're going to get a negative set followed by a positive set. Sorry, positive set followed by a negative set. So 5 pi on 3 is less than or equal to theta, less than or equal to 2 pi. That completes our circle. R is going to be negative. Okay, so that is going to give us some kind of feel for when r is positive and when r is negative, because that's important because we need to know when r is negative because that's going to affect the sketch. And we must make sure, of course, that we plot any negative r values in a dashed line. Right, so there's x and y, the y-axis, x-axis. Between 0 and pi on 3, that's going to be between kind of that direction and that direction. So let's draw a little line there. There we go. Let's call that theta equals pi on 3. Then r is positive in that kind of wedge. And then in the next sixth of a circle, we're going to get a negative r value. So that's going to be up as far as theta equals 2 pi on 3. So in that wedge, it's going to be negative r. Then in this wedge, it's going to be positive again. Then in the next wedge, it's going to be negative. So that's up as far as theta equals 4 pi on 3. And then finally down here, we're also going to have theta is 5 pi on 3. In that wedge, r is positive. And in this wedge back up to the x-axis, r is negative again. So we're going to get positive, negative, positive, negative, positive, and negative. Okay? All right. So looking at this first wedge, between theta is 0 and theta is pi on 3, we are going to end up with a positive r value. It's going to increase from a 0 up to a maximum, which will be at pi on 6, and then it would decrease back down to 0 again by the time we get to pi on 3. So it's going to look like some kind of loop, kind of like that. Okay, and that is going to be a petal on our flower. And if we keep extending keep extending theta past pi on 3, then we're now in this section. But because r is negative in this range, we're actually going to be drawing down in this section of the graph, and it's going to be a dotted line, or dash line. So we're going to get a loop like that, and then it's going to come back in there. And then between 2 pi on 3 and pi, it's positive. So it's going to come back in there like that and loop back round. And then between pi on 4 pi on 3, so in here, it's negative again. So we're actually going to be plotting in this quadrant. So it traces out that petal again. And then in that range, it's positive. So that traces out this petal again, but this time with a solid line. So we can go over that with a solid line. And then finally, in that range, that's this section over here, we get R is negative. So again, that traces back over that petal with a dashed line. And that is the Rhodonia when K is 3. And that's what the graph would look like. We wouldn't need to put in these theta equals lines. Okay, I've just put that there for reference so we can kind of break up going around as it went positive to negative. It's just those petals that you're going to need for the Rhodonia graph, okay, for a sketch. It doesn't cross the x-axis or y-axis anywhere except for the origin, so we don't need to label any intercepts. Okay, and that's it. That's the graph. Okay. All right, let's have a look at a situation when K is 5. So we're going to get a very similar setup, except now it's going to be flopping between positive and negative more frequently. So we're going to get between 0 and pi on 5, we're going to get a positive R. Between pi on 5 and 2 pi on 5, we're going to get a negative R. And between 2 pi on 5 and 3 pi on 5, we're going to get a positive R. And it's going to keep going all the way around until we get to between 9 pi on 5 and 2 pi. And in that section, we're going to end up with R is going to be negative. Okay. So there's going to be 10 wedges this time as opposed to the 6 wedges that we saw last time. So I'm going to draw my axes, which the axes would be needed for the sketch. So those 2 lines would be needed, but these next lines that I'm going to draw will not be needed for the sketch. Just going to put it there so we can more readily see the sections. I think it's probably slightly easier to start with 2 pi on 5 because that's going to be quite close to the y-axis. And that line there is going to go straight through, and then we're going to get a wedge in there for 3 pi on 5, and then cut those sections in half that way and that way. Okay. So we've got 1, 2, 3. The y-axis isn't a block. 4, 5, 6, 7, 8 again, cuts through the y-axis, 9 and 10 sections. And it's going to flip-flop between a positive and a negative all the way around. That should be negative. There we go. Okay, so we've got enough there to give it a sketch. So in this wedge, we're going to get a positive. And then in this wedge, we're going to get a negative, so it's going to jump through to the opposite side. So dash line. Then back into a positive. And then back into a negative, so dash line. Then we're going to get a positive. And then a negative, so a dashed line. But that traces over the petal that's already there. Then we're going to get a solid in this section. And then in this group, we're going to get a negative, so back over that petal with a dash line. And then in this section, we're going to get a positive. And then back into this section with a dash line, and then back to the start. And there's our Rhodonia for when K is 5. And we'll see this one's got 5 petals. So when K was 3, we had 3 petals, and when K was 5, we had 5 petals. So let's have a go at drawing that on the calculator. So in the previous video, we had a look at sketching polar graphs. So we need to change it and make sure it's in the right form. So the type is R equals. And then we're going to have sine of 3 theta. And I'm just going to modify the V window. Let's go between -2 and 2 in both axes. And I want to go as far as 2 pi. Okay, let's draw that. There we go. That's our first one. That was the one with 3 petals. And then if I change that K in there to a 5, then it will draw it with 5 petals. Okay. So there, that's the graph. So that's the only bit you would need to draw. You wouldn't need these extra lines that I've drawn over here. That was just to help me to draw it. But yeah, that's absolutely fine. Okay, Rhodonia. So K is 3, we get 3 petals. K is 5, we get 5 petals. Do you think you can make a guess as a relationship between K and how many petals we see? And then got that in your mind. Let's have a go at trying to draw this one. So you may have had a thought that it's equal to the number of petals, in which case we would expect to see 4 petals in this case. So sine of 4 theta, k is 4, so 4 petals. So we're going to draw this one. So between 0 and pi on 4, r is going to be positive. Between pi on 4 and pi on 2, r is going to be negative. And between pi on 2 and 3 pi on 4, we're going to get a positive. And between 3 pi on 4 and pi, we're going to get negative. And that's going to repeat again, because you want to go as far as 2 pi, because you want to go all the way around the circle. So that's going to be positive in that range. Then between 5 pi on 4 and 3 pi on 2, it's going to be negative. 3 pi on 2 and 7 pi on 4, it's positive. And then between 7 pi on 4 and 2 pi, r is going to be negative. Okay. All right, so drawing our axes, there's my y-axis, and there's my x-axis. I'm going to label your axes. And again, just like the other 2 sketches, I'm going to put in my kind of medium way lines. So I've got theta is pi on 4 and 5 pi on 4. And I've got 3 pi on 4 and 7 pi on 4. And the other ones are the axes. So 0, pi on 2, pi, and 3 pi on 2 are my axes. So in this wedge, we're going to get a positive, then a negative, then a positive, then a negative, then a positive, then a negative, then a positive, then a negative. Okay, so in this wedge, the petal is going to come out from the origin or the pole. It's going to turn at some point and get back to the pole. In this section, we're now negative, so it's going to push the petal out this way. Then in this wedge, we're positive, so it's going to draw a solid petal there. Then in this wedge, it's negative, so it's going to push it out to its opposite wedge, which is over there. Then in this one, it's positive, and we've already got 5 petals. And then in this wedge, it's negative, so we're going to draw a negative in there. In this wedge, it's positive again, so we're going to get another leaf in there, or petal. And then finally, in this wedge, it's negative, so it's going to push the petal out that way. And we end up with a Rhodonia with 8 petals, not 4. Okay. So, can you amend your rule as to what the number of petals should be if you didn't get it right in the first place? And just to clarify, we can do that on the calculator. Oops. And if I change that to a 4, we will see there are indeed 8 petals. Okay. So, what could be said about the rule now? Well, hopefully, if k is odd, then it has k petals. If k is even, then we have 2k petals. Why? Okay, well, we're going to delve into an animation shortly. But before we do that, I do have some static images here. So this is the case when k was 3. And then here we've got k is 2, which we didn't do. Then down here we've got k is 4, and then k is 5. And then down here we've got k is 6, and k is 7. So we can see when they're odd, we've got the same number of petals as the value of k, and when it's even, we've got twice as many petals as the value of k. But also, I want you to notice that when k is odd, there's like this wedge where there's no petal that's been drawn. Here, here, and here. So there's 3 kind of wedges to this shape where there's no petal. No petal, no petal, no petal. And that's because that when we were in that wedge for theta, what the graph was doing was it was redrawing the petal in the opposite edge. So yeah, we can only see 3 petals, but there are still 6 petals. It's just that 3 of the petals are hiding behind these. So actually each of these loops has been drawn out twice in the process of going from 0 to 2 pi. And the same thing occurs whenever k is odd. There's this wedge here where there's no petal drawn, and that's because while it was in that wedge, it was redrawing this petal. And when it's in this wedge, it was redrawing that petal. We don't have that when k is even. Every wedge has got a petal in it. And this was software that drew it, which is why I've got solid petals all the way around. But actually 4 of those should be dashed, and 4 of those would be solid. Whereas with the K, they would all be solid. And again, we can see there's gaps in this. K is 7 as we go around, whereas we don't see the gaps when K is 6. So the animation I've got is one where we're going to take the graph of the Rhodonia, and what we're going to do is we're going to vary K, but between the integers. So the Rhodonia is only called a Rhodonia if K is a positive integer. But we're going to just have a look at what happens in between those values of K, and we should see these petals kind of emerging and disappearing and reappearing. So let's see what happens as we animate this. So I'm just going to push play, and we can see that when K is 3, the petals are all on top of each other. K is 5, they're on top of each other. But when K is 6, there we go, we've got all the petals showing, 7 and then 8, and then back the other way again. So we can see these kind of petals are overlapping each other when K is odd, but we can see all the petals perfectly when K is even. I also want you to notice that as K varies between the integers, we've got this kind of petal appearing out of the x-axis, and they kind of emerge around as theta varies from the x-axis. And if K wasn't an integer and you extended it past 2 theta, then you end up with kind of more patterns and more spirograph looking shapes, which we don't study on this course, unfortunately, but you do get some interesting shapes that come out from that. But that's the reason. That's the reason we see half as many petals with odd numbers as we do with even numbers. Okay, and that finishes the video on Rhodonias. You do need to know those. You do need to be able to sketch these. Your calculator can do most of the grunt work for you, but having that knowledge in your head so you know what to expect when you're sketching them would be really good for this course. So as always, if you have any questions, please just drop them in the comments and I'll get back to you when I can. Thanks for watching.